Hello everyone. Today we are going to start a new chapter. Chapter name is Moments, Skewness and Kurtosis. We'll see one by one what all these mean. First, we will go to moments. Moments we can find in two ways. First one, moments about origin A, then moments about mean. So we can find moments in two ways. One moments about origin, and another one moments about mean. Origin can be A can be any value. A can be any value like 0, 1, 2, 3. Any number can come for A. So this A can be 0 or some other number, any number. If it is a equal to 0, we will simply tell it like moments. That's only. If it is a, we will tell moments about origin a. If it is about mean, then we will tell moments about mean. Okay. If 0 is telling, then directly we can tell simply as moments. Now we will see the formula. So moments are represented by m r dash. Okay, so MR dash is equal to, for ungrouped data, what will come? For example, first moment, we have actually a set of moment like a first moment, second moment, third moment. Likewise, we can tell. So how to write all the moments? First I will write, then we will write the general form. So first moment M1 dash equal to, we will write sum of all the entries by n, that is x1, that is power 1, plus x2 power 1 plus x3 power 1 plus etc. plus xn power n, sorry, power 1. All it is taken once at a time, whole divided by, this is how many terms are there? That is capital N terms, so this is capital N. So this is same as your summation xi, I is equal to 1 to n divided by capital N. This is same as your x bar. So first moment is always your mean. So remember this. Okay. First moment is always mean. Now what is second moment? M2 dash equal to, you have to square all the terms, that is x1 square plus x2 square plus etc. plus xn square whole divided by capital N, again divided by capital N. So this is equal to sigma xi square, I is equal to 1 to capital N, this is capital N, okay, divided by capital N. So this is called second moment. So this is second moment. This is first moment. Like that you can find third moment, then what will come? The exponent will be 3, and fourth moment exponent will be 4. Likewise you can continue. In general, what you can write? In general, instead of this 2, I am going to write as r. So everywhere I am going to write r. So you can tell general as rth moment, correct? So you can write mr dash equal to x1 power r, x2 power r, etc. xn power r. Okay, so you can tell this as rth moment. Okay, rth moment. So this is the general formula for mr dash. This you can. So only thing what you have to think, xi raised to r you have to find for each term. Then sum of the terms you have to take. Then divide by capital N. So that's how you have to find the rth moment. Now for group data. What about group data? For each xi you have a fi, that's in the group data. So in that case, how will you find it? The same way, mr dash is equal to, what you have to do? You have to multiply the frequency also with all the entries. So that is f1 x1 raised to r plus etc. plus fn xn raised to r whole divided by capital N. Here capital N is same as not just count, that is summation Fi, that is whole frequency you are taking to find N. So this is equal to summation Fi xi raised to r, I is equal to 1 to capital N. Sorry, here what you have to do is you have to write here it is small n, then the other one capital N. Okay. Okay, so sum is coming as capital N. How many terms are coming? N terms. That's only the concept. So here comes small n whole divided by capital N. So this will come as the rth moment for the grouped data. In the similar way, you can find this is we have found for a equal to 0. Now when a is some other number, what will happen? That we will write in the next page. So your moments will change to mr dash equal to for ungrouped. Here we have for a equal to 0, we have written this moments. So for if a not equal to 0, what will happen? You will get it as xr, sorry, yes, xr raised x1 raised to r, x1 raised to r minus it, x1 minus a raised to r plus x2 minus a raised to r plus etc. plus xn minus a raised to r whole divided by capital N. Or you can write this as summation x1 xi minus a whole to the power r for I is equal to 1 to capital N whole divided by capital N. This is your MR dash for ungrouped data. If it is grouped data, what will happen? The same formula is applicable with the frequency multiplication. So MR dash can be written as summation 1 to capital N. That is I is equal to 1 to capital N Fi into xi minus a whole to the power r whole divided by capital N. So when a is 0, you will get this formula. When a not equal to 0, you have to write by subtracting. Okay, so both case I have written a equal to 0 and a is any other number that is not equal to 0, that is this. Now in the same way, next moment is moment about mean. So now you can directly write the formula. What is that? Instead of here a, we have to take mean. What is mean? Mean is we are representing as x bar. So for ungrouped data, mr dash equal to, how can you write? Sigma x minus instead of a x bar. So I will write whole raised to r for I is equal to 1 to capital N whole divided by capital N. And for group data mr dash equal to sigma, you have to multiply frequency, that is fi into xi minus x bar whole raised to r for I is equal to 1 to n whole divided by capital N, where capital N is equal to sigma fi. Okay, so all formulas are one and the same. In this formula, when a is 0, you will get just moments. When a is non-zero, you will get moments about origin a. When the in this place if you have x bar, then we will tell it as moments about mean. That's the three types of moments, or rather two type moment and a particular case, that is for a equal to 0. So remember this, what is mean? That is mean is the first moment about origin 0, or first moment only you can tell. So remember the formulas. Ultimately you remember this formula. This is a moment about mean, and for this notation there is a slight change. You will represent this as mr alone. So remember that for the other two we are writing mr dash, but for this we will write mr alone. So moments about mean is written as mr. R. There is another name for this at central moments, but it is not written in your text. So we will call it as moments about mean, and it is denoted by MR for ungrouped data and for grouped data. It is formula is same, only Fi is multiplied, but that's only the difference. So hope you have understood the types of mean moments we have. Now we will see problems for both case. Before that, one more thing you have to learn, that is the relationship between this moments about mean and moments about origin. Okay, so how will you do that? The following relation exists between moments about mean and moments about an arbitrary origin, that is like arbitrary origin A. So you can connect like this. First one I can write m1, that is equal to m1 dash. Sorry, m1 is, what is m1? Just see, m1 is equal to, by formula, what will come from, by formula raised to r will come 1, correct? So you will get sigma xi minus x bar whole to the power 1 divided by capital N. Now, so this is equal to sigma xi minus sigma x bar 1 to 1 to capital N divided by capital N. So this is equal to sigma xi by capital N minus x bar is a constant, so you have to add the constant n times, so capital N x bar divided by capital N. So this n and n will cancel. Sigma xi by capital N is same as x bar minus x bar again, that is equal to 0. So means first moment about mean is always equal to 0. So remember this always. First moment about mean is always, that is m1 is always equal to 0. Okay, then m2 we can write in terms of other moments, that is m2 dash minus m1 square. Then m3, this is 3, m3 can be written as m3 dash minus 3 m1 dash m2 dash plus 2 m1 dash cube. Then m4 is equal to m4 dash minus 4 m1 dash m3 dash plus 6 m1 dash square m2 dash minus 3 m1 dash raised to 4. This formula you have to remember. Then only you can do the problem easily. Problem will come in this way: find moments and moments about mean for the given data. So no need to find moments about the mean separately. What you have to find? You have to find the moments first, then use this formula to find m2, m3, m4. m1 is always 0. In whatever be the data, you will get m1 0, m2, m3, m4. You can find using this moments formula. Okay, so once you have moments, you will have the moments about mean as well. No need to go for this particular formula. If they are directly asked to find moment about mean, you can use this formula. If not, you can use this relationship to find moments about mean. Now let us see one problem from each. So first one, ungrouped data. So here it is. The set is given 2, 3, 7, 8, 9. First, second, third, fourth moments we have to find. So let us see the first moment first. So what will come? M1 dash equal to, have to add and divide by, what is capital N here? How many data is there? 5. So m1 is equal to, you have to add all the data, 2 plus 3 plus 7 plus 8 plus 10. This is the formula, divided by capital, that is 5. What is m2 dash? M2 dash is equal to 2 square plus 3 square plus 7 square plus 8 square plus 10 square divided by 5. Now, what is third moment? This is first moment. First, then second, then third. Okay. So, this is equal to 2 cube plus 3 cube plus 7 cube plus 8 cube plus 10 cube divided by 5. Then next moment, fourth moment, m4 dash equal to, what you can write? 2 raised to 4 plus 3 raised to 4 plus 7 raised to 4 plus 8 raised to 4 plus 10 raised to 4 divided by 5. So you got your m1 dash, m2 dash, m3 dash, and whatever you have to calculate the values, then you have to write here. Once you get calculated value, you can use that values to find the moments about mean. Here we are asked to find moments about the mean, so that also you can find. So how to do is, first let us write the sum of these formulas. Here we have the answers. So you have the values, first x bar. See, remember one more thing. Here m1 dash they have written as x bar, because I told m1 dash is same as what? M1 dash is same as your mean, correct? This is mean. So x bar. So all the others written in this format. So I can write my m2, m2 bar, m2 bar, m3 bar, m3 dash, m4 dash. All these are moments. This I can write in another form for this particular moment. If you're asked to find moments, what do you have to find? Moments means moments about 0. About 0. Okay, so this is x bar, x square bar, x cube bar, like, so this is x bar, so this is x square bar, because x square terms we are finding the mean. Here x cube terms we are finding the mean. Here x raised to 4 terms we are finding. So you can write in this way if you are asked to find just moments. So no need to write in this format, you can write in this format as well. So these are the moments. Now you have to find the moments about the mean, correct? Moments about the mean. Two ways you can do. One, you can do directly using the formula, or you can use the relationship to find the moments about mean. So first I will show you how to use the formula, then I will show you how to use the relationship. Okay, so for the next page we are going to use the formula. So this is the central moment calculation. Here you just see first m1. They have calculated here in this text, but we already got it as 0. Whatever be the data, that will be 0. Then m2, that is x minus x bar whole square bar. That, or you can write the sigma x minus x bar. Mean it is x bar whole square. See the definition formula. I can show you this, right? Xi minus x bar whole raised to r. So whole square, whole cube, like the terms will come. That's what they have written here. So first x is 2, and your mean you have, what is your x bar? Already you have calculated. What is your x bar? That is 6 here. X bar is 6. First moment is called the mean. Okay. So you have to subtract from each entries, that 6, then divide by 5, that you will get 6. M2 means each entry you have to subtract and square and uh, divide by 5. It is 6 written. Okay, 5. So this will come 9.2. Then remember one thing, and this M2 is called the variance. So you may check the variance formula. This will be the same for variance. Standard deviation was root of this. So square of standard deviation is your variance. S square is representing as your variance. So second moment about mean will give you variation. Hope you have learned the term variation in the previous chapter. So variation or square of standard deviation, that is same as second moment about mean. Then third moment, that is same way, x minus x bar whole cube by n. So each term subtracted the mean, then cube you have found, then you have found the answer same way m4 as well. So we got all the moments here. Now what you can, this is one way of finding, yeah, moments about mean. Now what is the next way? You can use the relationship, that is, this is the relationship. So you have already what is m1 dash, m2 dash, m3 dash, and m4 dash. Substitute in this formula and check whether you are getting same m2, m3, m4. What is m2, m3, f4 you got? 9.2 minus 3.6, 122. That is a homework verification. Okay, homework is verification of relation. So the relation between moments and moments about mean we have to verify using the these values. Either you can find your moments from that, or moments about mean from that, or you can verify both. Either way you do, no issue. So remember one thing, to find moments about mean, it is only required to have moments alone. If you have moments with you already, you can find moments about mean. No need to perform this formula. Yeah, and one, if you're asked to find moment directly, then you can use the formula to find. And verification also can ask, then you have to find both values using formula. Then verify means you have to substitute in the given relation. What is the relation? We have four relations. One is m0, other three relations are there. All the three relations should be satisfied by whatever be the values obtained for moments and for the moments about um mean. Okay, so this is the way. Now let us see one data for a grouped one. So grouped, this already, this table is familiar for you now. The same data we are using in so many places. So here frequencies is written and the class is also written. So how we'll write the class mark, this is written. Then you are using the coding method here. You can always use this coding method everywhere to make the problem simple. So coding method means what? You have to do u equal to something, that is x minus something what you have subtracted and divided in the previous problems we have done. We have taken the maximum frequency and class mark, that is 60. So you have to subtract 67 and divide with common factor. So when you divide, what is the common factor comes here? When you subtract, you will get um, 64 minus 67 is minus 3, then minus 6, here also 3 and 6. So 3 is a common factor, so divided by 3 you are doing. So x minus 67 by 3 is your u. So that's it written here. Then usual procedure we will do, multiply f and u, you got fu. Then what else is needed? You need, instead of x, now instead of x we are going to consider u alone. So don't look at x now, only you have to check u and f. So in the formula you just see what is the formula for group data. For grouped data we have fi into xi minus x bar, and for the other one fi xi raised to r. So these terms you have to find here, then you have to find the sum, then divide by n. So that's what they are doing here in this. So sum of f, that is capital N, is found, that is 10. Then f into u they have found, that is sum is 15. Then f into u square, that also found sum is 97. Fu cube and fu raised to 4. Then what they have done, first moment. What is first moment? You have to see this c, you have to multiply with this sigma fu by n. How it comes, I will show you. Your u is equal to x minus some capital A divided by C, correct? Or some K you just take. Or C is the terminology used, so C we will use. Okay. So what will happen when you substitute over here, when you find summation fu equal to summation f x minus a by u, correct? Okay, so or in another way, if you write, you can make it in another way. So this is x is equal to cu plus a. So x bar is equal to cu bar plus a. Okay, so once you subtract this subtract this point, so what will happen to your m1 dash m1, we have to find about origin, right? So x bar minus a equal to c u bar will come, correct? So here to find your to find x bar minus a, you have to multiply c with your u bar. That's why they have multiplied c here. Okay, so only thing you have to remember is when you consider u, you have to multiply c. In the other case, there is no c. Just I'll show you the formula. This was the formula, sorry, this was the formula for about origin a. This is for just this. So this was the formula. Here xi we are used. So once xi is converted to ui, what will happen? You have to multiply that multiplication c fact, whatever you have divided throughout the entries, that you have to multiply here. Then sigma fi ui square divided by, not square, raised to r. It's common term, all right? R. Common term is R. So remember this thing. If it is x, there is no c term. If it is you are converting xi to u, then you have to multiply the c with the terms. That's what they have done in the table. That is called coding method. So c multiplied, you are getting m1 dash. If you take m2 dash, not just one c, what you have to do, because it is square comes here also, c square multiply, and here u cube, then c cube multiply, u raised to 4, c raised to 4 multiply. You will get all the moments about the origin. Now to find the moments about mean, they have used the relationship between moments about mean and moments about origin. So they have written these two values, we have substituted and found all the four moments about mean. This is always zero, no need to calculate. Other three only you, you have to calculate. Hope the idea is clear. Only thing is we have two formulas. What are the two formulas? First one, we have, wait, we have for moments about origin a. A can be 0 or a can be any number. If a is 0, we will write m1 dash in this way, that is sigma xi by n. This is all raised to 1, it is not dash. Okay, if you are getting confused with the dash, I will wipe all this. Okay. So x1 plus x2 plus etc plus xn divided by n. In the same way, m2 dash will come x1 square plus etc, m3 x1 cube plus etc, likewise. So common x1 raised to r, in this form generally we can write that is the rth moment. First moment is always mean, remember that. Group data, same formula with frequency you have to multiply. When a is not equal to 0, any other number, our formula will change like this. You have to subtract that a from each entries of x, then you have to find power r. Instead of x1 raised to r, we have x1 minus a raised to r. That is for ungrouped data. Group data, same thing with fi, you have to multiply. If you are subtracting x bar instead of a, that is called moments about mean, and it is represented in another format, that is mr. Other one was mr dash. So if it is origin, we have another representation that I have written here, that is represented as xr, x raised to r bar. This powers of x, that mean they are taking, so x raised to r bar. So that's three formulas. Same formula for mean with subtraction x bar and frequency multiplication for group data. Then the relationship between this you have to by heart. For finding m2, they are using moments up to 2, and for finding moments about mean 3, they are finding up to 3, and you just note down the coefficient how it is written. You have to by heart it. That's the only way. By heart the relationship, then you can find mean and moments and moments about mean using this formulas. So write down all these problems neatly in your notebook. Calculate yourself whether the values are coming. Find first moment, second moment, third moment, fourth moment, then first to fourth mean moments about mean as well, and verify whether the relationship between these two are satisfied or not. Hope it is clear for you. Thank you for today.